Alright, this is where a lot of this stuff comes together, and if you've got siblings that did methods or spec ahead of you, you've probably seen this diagram on their cheat sheet. Some kids like to say that you should memorize all of these angles. I don't think so. I'm going to show you how to find the first one, how we find these, and then you might not have to memorize the whole triangle, the whole circle. So, angles in the unit circle. It's useful to see how angles on the unit circle can be stated in terms of degrees and radians. The key to doing this is remembering what the circumference of a circle is. Can someone remind me what the formula for the circumference of a circle is? C is equal to something. Good. So, because of that, and because I explained to you that a radian is how many radiuses of a rotation you go around a circle, how many radians are there around a full rotation of the circumference of a circle?
One.
No?
2 pi.
Yeah, because I've got 2 pi radii, 2 pi radiuses around the circle. How many radians would there be? Also 2 pi. It's going to be in the, it's going to be in the video.
Like the low.
We don't know who it is. So what can we say? A 360 degree rotation is equivalent to 2 pi radians. So we have a whole unit circle here, and in red I'm going to write in degrees, and in blue I'm going to write in radians. If I have rotated 0 degrees, how many radians would I have rotated through?
0.
Also 0, 0C. Based on what we just discussed here, a 360 degree rotation is from this line all the way around. How many radians would that be? 2 pi. 2 pi radians. That gives us the building blocks to complete this. Because if 2 pi is the whole way around, how many pi would be halfway around?
Well, 2 pi over 2, which is just pi.
Which just single pi. So this is pi radians. How many degrees is this?
180.
Good. Let's break it up. We're slicing this pizza. Okay? Halfway here, this. How many degrees would that be?
90 degrees.
90 degrees, and then 90 degrees. But yeah, that's fine. You're correct. Just speed running my questions. So if this is pi, what's half of pi? Pi over 2. Pi over 2 radians. How many degrees would this be? 180 plus 90 would be 270 degrees. What fraction pi would that be?
3 over 2.
3 pi over 2. Or 3 on 2 pi, but what you'll notice in the book and your teachers will write is 3 pi over 2. All the same thing. Let's slice it up even more. I've got more people at this party. I need to cut it a bit more. What do you think this solid line is representing? It's not perfectly drawn, but I've tried to fit 1, 2, 3, 4 solid line slices in there. What angle do you think that is in degrees?
45.
Good. So this should be 45 degrees. In terms of pi, in terms of radians, how many pi radians would that be?
Pi over 4.
Good. See what I mean by I'm showing you how to work it out? I've seen a lot, and this is how I was taught in high school. They just taught me to memorize it. But if I know how to put it together, I can work it out whenever. Okay? What would the, what angle is this?
3 pi.
And?
3 pi over 4.
Good. So this is 130 degrees, which is also 3 pi over 4. Next one.
It's not 130 degrees.
135.
It's 135, my bad. That's on video. See? We're all fallible. You're not going to downvote that one. What angle is this? 225 degrees. What fraction pi would it be? This is 4 pi over 4, that's why it's pi.
5 pi over 4.
So this would be 5 pi over 4. 6 pi over 4 cancels down to 3 pi on 2. It all freaking the maths makes sense. Oh my god. What would this be as an angle? 360 to take 45?
315.
315 degrees, which would be
7 pi over 4.
7 pi over 4. Why does that make sense? Because this would be 8 pi over 4. 8 divided by 4 is 2 pi. What angle do you think I'm trying to represent with these dotted lines?
30 degrees.
Good. So this is 30 degrees. In terms of pi, what would that be?
Pi over 6.
What? Yes. If you're not sure how to work that out, this half a rotation is pi. How many dotted slices do I have in that 1 pi? 1, 2, 3, 4, 5, 6. Pi over 6. So this is pi over 6. Let's smash out all of the radians very quickly now. Pi over 6, 2 pi over 6, pi over 6, this would be 2 pi over 6, which would cancel down to?
Pi over 3.
Good. Pi over 3. What angle would that be in degrees?
60 degrees.
Does that make sense in terms of, that would be 3 pi over 6, which cancels to pi over 2. What angle would this be?
4 pi over 6.
Which cancels to?
2 pi over 3.
I did too many texts. If I drop one on my white shoes, I'm going to be very upset. But what angle is this?
120.
120 degrees. What would this one be?
150.
What radians would that be?
Um,
Pi over 6, 2 pi, 3 pi, 4 pi, 5 pi over 6. 6 pi on 6, 7 pi on 6, 8 pi on 6, which cancels down to 4 pi on 3. I'm not going to do the degrees anymore. This should be making sense now how I would complete this. 8 pi on 6, 9 pi on 6, 10 pi on 6, which cancels down to
5 pi on 3.
5 pi on 3, 5 pi, 10 pi on 6, 11 pi on 6, 12 pi on 6, which cancels down to 2 pi. Okay? So, yeah, if you've had past siblings, you'll be like, I memorized that. I don't think you need to memorize. You can work it out for yourself. Okay? Now, these examples that I'm showing here is so that you are covered while I'm away next week. Okay? I'm loading you with teaching right now because I'm going to be away. So these examples are going to help you with exercise 5C, which investigate degree and radian measures and the sine, cos, and tan of angles on the unit circle. Make sure you got your calculator ready for me. A big part of it is completing tables like this below. So if I've got a 0 degree angle, how many radians is it?
0.
0. So we're talking about the angle formed by this line here. Okay, going across here. What's the sine of that? How far vertically has it gone up or down if I'm pointing there?
0.
0. But what's the cos? How far horizontally have I gone? 1. Tan theta is going to be
0.
sine theta over cos theta, 0 divided by 1. The thing that we can't have is a 0 on the bottom. That's undefined. But the 0 is on the top here, so it remains as 0. Let's consider 90 degrees. 90 degrees, what did we just establish that was in radians? Pi on
2.
What's the sine here? How far vertically has it gone?
1.
1. How far horizontally has it gone?
0.
0. 1 divided by 0.
Undefined.
When the significance of this, I wish I had time to teach you this year, but the significance of that will become clear when you do. I think it's like one of the chapters where you're, yes, chapter 7, where the graph of tan looks like that. It goes across and then it never touches a. It's got an asymptote. It's got an asymptote when the angle is 90 degrees. Okay. 180. 180 is how many radians?
Pi.
Pi radian. How far vertically have I gone if my angle is pointing that way? No, not
0.
Okay. How far up? I've only gone 0. How far across? What direction?
-1.
Good. So there's like a pattern to this. 0, well that's just going to be 0. Now let's think of 30 degrees. Here, this is where you'll need your calculator. So, 30 degrees is what? Pi on 6? What's the sine of it? I don't know. I'm going to teach you that on Friday, but right now, the only thing that we can do to find the sine of this is to use the calculator.
It's 0.5.
0.5.
1/2.
So what that's actually telling me is if on the unit circle I've turned 30 degrees, or pi on 6, this is actually exactly 0.5 up. Okay? The significance of that will become clear. Okay? What about cos of 30 degrees? Can you quickly find that for me? Cos of 30 degrees will be a not nice number.
0.866.
0.87, 2 decimal points. What would the tan be? So 0.5 divided by 0.87. It's not going to be exact. Got it? 0.5 divided by 0.87.
Yeah. 0.57.
0.58.
No, it's not. It's 0.574.
Yeah.
Round down.
0.57. Okay, Angel and I, we don't need fisticuffs on my video. 45 degrees. What's the radians of it? Pi on?
4.
What's the sine of it? It's not going to be a nice number.
0.71.
GDP?
Mm-hmm.
Can you tell? Because this is 45 degrees, and he's just worked out that the vertical distance for 45 degrees is 0.71, what should the horizontal distance also be?
0.71.
It should be the same. You show me, cos of 45 should be what?
In the calculator is 0.71 as well.
Yeah. And that divided by that should be 1. That's very convenient for us because all we've been dealing with is triangles that look like this, which is nicely set up. But how the heck do I deal with anything that's beyond 90 degrees? What if my angle was all the way over here? Okay, I need to show you that too. So how do I deal with that? Just remember that sine theta is the y coordinate of the point, cos theta is x coordinate of the point, and sine, cos, and the radius form a right angled triangle. So if I was doing 150 degrees, do you agree that that sort of looks like 150 degrees? I can't deal with this triangle. I can't do anything with that. But if you remember these points here, do you agree that if I drop P down, have I formed a right angled triangle pointing to the left? So I've just drawn a big version of it here. I zoomed in. What did I say sine theta was? It's how far up I go. That's how far up it went. Is cos theta how far left or right I went? Is it going to be negative in this case because I went to the left? But you just need to decide where is theta going to go in this triangle so that sine is opposite over hypotenuse. Because I can't. If I chuck that there, is that going to be right?
No.
Which corner should theta go so that sine is actually the opposite over hypotenuse?
You put it in the corner that's touching the origin.
Theta here. So let's text. How do I deal with this? How do I do this maths? Well, we've already done this for degrees 150 degrees. How many radians is 150? 5 pi on 6. What's the sine theta of that?
It's 0.5 again because it's 30 degrees away from the
Good.
180
So
mark.
what he's done is gone, well, 30 degrees. I don't know what this is, sine theta over 1. So you just go sine of 30, you get that. So what is it? 0.5?
0.5.
What do you get for the cos theta?
negative 0.87.
Does that make sense? That the cos theta would be negative 0.87. What direction am I going horizontally in this triangle? Am I going to the left? Is that correct? Is it to the left of the origin? Yes?
Yes.
And then what's tan theta going to be?
Negative 0.57 because you're just switching the sign for the...
to 2dp. Now, what you will do on Tuesday next week is you're going to find these numbers that will clean this up. We're doing an approximate, but there's a question in there that everything will become clear, okay? But just not right now, okay? That's the end of that video. I'd like you to have a break and then make a start only on 5C.